Hello, and welcome back to another episode of Year 12 Chemistry, where I stare at a computer screen and talk to myself for an hour. Today we will be looking at dot point 6.4, which is the analysis of commercial electrolytic cells with reference to their operations in given contexts. This is the skill that you want to be able to master. This will give you the most value for your time and energy and effort because I can guarantee you that you're going to get a question like on this in the exam. This is also one of the skills that students struggle the most in Year 12 chemistry, probably considered one of the hardest skills. And the reason for that is because you need to essentially be able to apply your understanding of redox in general and electrolysis in particular to unfamiliar situations. Every year you will get a different electrolytic process and it will look slightly different, and you need to be able to react to that, which is why people find it so terrifying. But hopefully, I'm going to go through a few examples and try to give you some strategies. And honestly, if you do enough question, maybe like 10, you will see that it's just the same thing. It's like maybe five different things, and then it's either this or the other. There are a few different types of questions that they can ask, but it's really not that bad. All right. Anyway, we're going to look at these three specific examples today. So this is the first one, which I drew that diagram. I did not draw this diagram. This is the second one, and I definitely did not draw that. This is the third one. I think another thing that they do a lot, especially in assessment, is they just give you the most terrifying looking diagram that you can possibly see, and that in itself is enough to terrify people. So just it's just a diagram. It's not going to do anything. This one looks like a person wearing sunglasses. Anyway, so one of the reasons why students find this particular type of questions so difficult is because it actually requires you to have a really good understanding of redox and electrolysis. So if you're not there yet, you're going to really struggle. So it is really important to assess yourself and to see where you're at and to see whether you should go back and do some revision of previous topics and previous skills before you attempt this one. So we talked about this table last lesson, and I think this is your starting point. At least you need to understand everything on this table. So if you don't know what backward Z means, and if you don't know the difference between galvanic electrolysis, it's probably a good idea to stop this video now and do some revision and then come back to it. Otherwise, I don't think it's going to work out too well. All right. Now, this is generally what I tend to do when I look at a new, either a lab electrolytic process or a commercial electrolytic process. And the difference between the two is just the commercial one, it's on a larger scale. And a lot of the times you will see something that can be produced in the lab, but in order to scale it up, it's actually quite challenging because of the cost, let's say to maintain a certain temperature or to produce the catalyst. And we'll talk about some of these things later. But when you look at a new lab electrolytic cell or a commercial electrolytic cell, the first thing you probably want to ask is what is the purpose of the cell? Unlike galvanic cells, which only supply electricity. So when you look at any galvanic cell, you can say, oh yeah, this is just a battery. You build this so that you can have electrical energy. An electrolytic cell can have a range of purpose because I think we mentioned earlier, or even in this diagram, it is used to produce chemicals. That was the purpose in general. But when you look at a specific electrolytic cell, you need to identify exactly which chemical is being produced. And there are some other applications as well, and we'll talk about those not today, but maybe in the future. So identify the chemical that is produced or identify the purpose of the cell is really important because when you analyze the cell, whatever you get as an equation or as the products have to match the purpose. Everything has to go back to the ultimate purpose of the cell. Okay, so that's the first question. The second question that you probably want to ask is just the general operation. How does a cell operate? A few things that probably will help you if you're stuck and you don't know where to begin. I will start by finding the cathode, the anode, the electrolyte. So the three key features of electrolysis. A lot of the times, these drawings will not have a power supply, but the question will say that it is an electrolysis process, so you know that it's the electrolysis. Um, in very, very interesting situations, the power supply is going to be in the form of a galvanic cell. So you essentially have to analyze a galvanic cell and an electrolytic cell at the same time. Hmm. Now that would be a good question, don't you think? So we're gonna go cathode, anode, electrolyte. So just identify the three, just to give you some pointers, and then think about the half equations. Now, in order to write the half equation, you may need to use the electrochemical series and apply the skills that we talked about last lesson, when you have to list all the species present and then identify which two undergo oxidation and reduction. So use electrochemical series. Okay, and flow of ions. Flow of ions is important because it allows the cell to operate. So you want to make sure there is no buildup of ions. Um, as a general rule of thumb, depending on what type of ion is being produced in the cell, but as a general rule of thumb, and I think this works all the time, cations will flow towards the cathode and anion flow to the anode. Anions flow to anode. Okay, and lastly, we're going to look at collection of materials, and this really depends on the context. I'll talk about this when we go through the specific examples. But if the purpose of the cell is to produce a substance, you want to look at any desired feature that the cell may have to be able to collect that substance easily. Say, for example, a cell is producing a gas, there has to be some strategies there to collect the gas. You really just don't want it to rise up and goes everywhere. Questions, well, not the question, but the third thing, well, it is a question that you might want to ask yourself is, what is the function of each component of the cell? If you truly understand how an electrolytic cell operates, I can point at any feature of the cell and ask you, why is it there? And you should be able to answer it for me. And sometimes this is the type of question that you see in the exam, when they will say, what is the function of, and then they will cite a specific component. They're not going to ask you this general question. They're going to go specific. They're going to specifically focus on one component. So that's one way that they can ask the question. So if you look at a diagram, and you're going to see a lot of diagrams today, make sure that you can explain the function of every feature in that cell. Some other times, and this is probably the more advanced version of this question, is they're going to ask you to predict what would happen if you remove a component, or this is probably the more common one, if you replace a component of the cell with another component, what would happen to the operation of the cell? And you really need to think about what new material is being introduced if you replace with another material, and how that new material may compete with the existing operation of the cell. So there are two things that I would recommend doing when you see a question like this. Is you want to, again, use the electrochemical series. You want to think about the strength, the oxidizing or reducing agent strength of the new material. Is it going to compete with anything that's already in the cell? So use the electrochemical series again. Always use the electrochemical series. That's just a no-brainer. And you want to link your answer back to the operation of the cell. A lot of times students forget to fully answer the question. Ultimately, if the purpose of the cell is to produce a substance, you want to, in your answer, you need to tell me how is this replacement affecting the cell's ability to produce said substance. So you can't just say, oh, it's this thing is stronger than the other thing, and stop there. That's not fully answering the question, and that's not showing an understanding of the context. So always bring it back to whatever the context of the cell is. Okay, so that's just the introduction.